Hello, everyone, and welcome to our second lecture of our second series about machine learning from a simple line to generative AI. Today's lecture is going to be about the positional encodings and attention in machine learning. As usual, we have our guest, Dr. Khalid Mahmoud, and your host is going to be myself, Ali Al-Wadi, and I believe we introduced ourselves in the first lecture. So yeah, let's jump into it. And yeah, Dr. Khalid, you have the mic. Let's start.
Thank you, Aliwadi, for the very nice introduction. So we will start by a quick outline. The first thing is we will refresh on matrix multiplication. And after that, we will take a break from the AI and from the machine learning and from computer science. We'll just focus on our life perspectives. And then after that, we will introduce a mathematical model for QVK, and we will explain what that is once we reach that. And then we will introduce the concept of positional encodings. And at this point, should be able to understand what is the transformer architecture. So to start, we have mentioned earlier that once we represent daily life objects and concepts in mathematics, we can use and utilize and harness the full power and magic and the established rule of mathematics to draw conclusions and make predictions. And the better and the more accurate we represent these objects in mathematics, the better our insights and predictions will be. Example of these concepts are products. For example, when we talked about product recommender systems, when we represent a product as a vector and another product as a vector, and we measure the angle between them. Languages, as in large language models, and then context, and then also the concept of time. So we need to refresh a little bit the concept of matrix multiplication. This concept can be a little bit tricky because it is easy to forget, and it's easy to forget how to multiply that. So we're going to introduce a simple model, a simple mind map or mental model for that is when you multiply a matrix, you always multiply a matrix by a column. Always remember this. A matrix on the left is always multiplied by a column on the right. And how do we
Yes.
multiply a matrix by a column? Is you take a linear combinations or you take a linear combination of the columns of the matrix to the left. What does that mean? For example, this column here, you multiply A by the full column C1. And that means is you multiply A by each element in the column. You multiply B by the column C2 and C by C3 and D by C4 and so on. And then you sum all these columns together. So we'll always see matrix multiplication as multiplying a matrix to the left by a column to the right. What about if you multiply a matrix by another matrix? It is the same actually mental model and the same approach. We always multiply a matrix by a column and then you multiply a matrix by the other column and then we just combine them in a nice resultant matrix. So we have a concrete example and we will let our host Ali explain this matrix multiplication for you.
Sure thing. Thank you, Khalid. Uh, as you can see in this example, Khalid has made it easy for us to explain the process. To be honest, it's a very small numbers that's easy to maintain. So the column in the second field in the multiplication equation on the left must be multiplied by in order by the columns in the matrix in the first. So you can see how in the block in the middle, so this translates to 2 multiplied by the first column and 3 multiplied by the second column. It's the one highlighted in red. Again, Khalid made it easy for us even with the colors. So this results in 2 multiplied by 5 added to 3 multiplied by 0, and hence you get the results 10. And then in the second column in the result matrix, you will get 2 multiplied by 2 added to 3 multiplied by 2 from the second, and you will end up with 10 as well. 2 multiplied by 3 and added to 3 multiplied by 1, and the result is 9. As you can see, just one row multiplied by one column. As simple as that. Back to you, Khalid.
Thank you, Ali. It's always, if you were to take out one thing from these three slides, is when you multiply a matrix by a column, the column dictates a linear combination of the columns of the matrix. That's it. A
But I think,
column,
Khalid,
yeah.
we still need to explain to the viewers that what do we need this for? I'm sure
Oh, yes,
you
sure,
will
sure.
explain in
Agree,
the next
agree.
few
So we
slides.
will need, once we start talking about the inner workings of the LLM, we will use matrix multiplication because in the previous lecture or the previous presentation, we have shown how to represent a word as a vector. And there is a lot of vector transformation operations in LLM. So it's good to know how to do matrix multiplication. We like this is a basic thing in general, and also in machine learning it depends a lot on linear algebra. For example, recommender systems, right? When you calculate the dot product and when you represent everything as vector, so it's very important to be able to have this to review this very basic operation.
Okay, yeah, sounds good. Let's proceed.
So now we're gonna take a little bit of break from the artificial intelligence and machine learning and even computer science. And we're just gonna talk a little bit wisdom here, just a little bit. So there is an old piece of wisdom that says you are who you hang out with. Because when you hang out, you pay attention to the behaviors and the mentality to the people that you hang out with. Some people might, everyone might influence you in a different way. Somebody that goes to the gym and exercise might push you to go to the gym and be more active. Someone that smokes, smoking is contagious sometimes. So he might affect your behavior and convince you to smoke. Somebody that's very knowledgeable on like science and technology, he might also affect
It's a
you. You
culture
become more.
habit, yeah. Culture
Exactly.
habit that people, inherit from, from culture, from people you hang out with.
Exactly. And also Ali Wadi has kids, I'm pretty sure. So to best raise your kids, you need to pay attention whom your kids hang out with too, right? You need your kids to hang out with people
Absolutely.
that
That's
don't do drugs, you know. Yeah.
every parent's concern.
Exactly. You need to be respectful to people, right? You don't want somebody or your kids to hang to somebody that insult other people or look down to other people. You need your kids to be respectful, contributing to the society and to the community they live in. So that also whom they hang out with, either in school or in the gym or even your neighbors, that affects their personality. So this is just a small illustration, a graphical illustration of the effect of personality influence that each person affects you in different way. For example, your best friend might have a heavy influence on your thinking and your mentality, and then maybe your neighbor didn't hang out with him, or there's not much in common, so he affects you in a little bit way. Maybe he take care of his backyard, so you learn that from him. And your coworker might have a little bit of influence on the way you work. Maybe he just influences you inside your work environment. So there are many aspects to our life. And these aspects, for example, personal growth, money, saving money, and career, you want to grow in your career, relationship, parenting, and family. And in each of these aspects, you go out and do some activities like going to work, going to the gym, take a walk, hike. And in each part of these activities, you meet people that will influence you in a specific way. So let's look at the gym aspect of our lives. When you go to the gym and you meet different people, your objective at the gym, for example, you might be already fit. You are not overweight, you are not underweight. And there's nothing wrong with being overweight. You pay attention to the people in that context based on your objectives. The bodybuilder might know the exercises very well. He might teach you the exercises very well. He is already there. So you listen and you pay a lot of attention to what he mentions. Also, the nutritionist in that context, she will tell you what to eat, what not to eat, and when to eat. And there might be a politician. Maybe he is a little bit overweight or too overweight. and he doesn't know a lot about fitness or even healthy eating, but he talks a lot. He eats your head, so you probably get affected a little bit by what he says. So you started eating fries. Maybe that's unhealthy, but he affected you. You pay a little bit attention to him. And then there is the economist, and then there is the doctor, and then there is the teacher or the professor. You don't pay attention to them because they're not gonna add a lot to your fitness aspect or perspective or to how you practice in a safe and eat in a healthy manner. Same thing, the politician also, because you are already fit, not overweight, not underweight, you eat healthy. The politician that's a little bit overweight might pay more attention to you. Maybe he's 80% interested in you, while you are 50% interested in him because you're already there and he want to learn how to get there. So not every you pay attention to somebody and he may pay attention to you in a different manner or a different amount. I think Ali, you have a very good example about hiking, so I'll give you the mic here.
Yeah, actually, I can contribute with a very good example. When probably 12 years ago, when I moved from Jordan to New Zealand, I was introduced to the new beautiful nature of New Zealand. So I kind of got engaged with a few groups that do hiking and kayaking as well. One of them in particular, he's currently in Melbourne, Australia. And that guy was a very, very enthusiastic hiker. And he used to memorize all these good hiking tracks and then tells you where the good hike tracks with the rivers that, they cross the river or where there are bridges and enough water and whatever. Or cave exploring and whatever. So I used to pay a lot of attention to that particular guy among all of the others, just because,
He's an
first
expert hiker.
exactly, he's an expert hiker. Yeah. Yeah, so I'll give you the mic back, Khalid.
Thank you. That's a very good example. And let's take a look at another context when you want to start your own business. You might join a startup forum and assume you see me the same people. Now, the politician that you really did not give much weight in his advice or to what he says, you probably now give him more attention because he has a lot of contacts. He has a lot of contacts, he has a lot of connections, and there is an adage or a saying, it's not what you know, it's who you know. So definitely he will help you, maybe give you the right advice, what's the right business, and give you the inner details and the secrets of business success. And the economists that you probably gave 5% in the previous context, on the previous slide, you now 50% of your business aspect might be shaped by what the economists say to you. So this is an example that in life has different aspects, and each aspect there is where you are in that aspect. Are you fit? Are you rich? Are you poor? Do you have debt? And then you have an objective, and based on that objective and based on where you are, you listen and you listen to different people differently based on the aspect. So this is just summarizing what we said before. We have different aspects of life, the gym or the fitness aspect and the startup aspect, and this is how you pay attention to each person separately. The politician that you only gave 10% in the gym aspect, you gave him 40%. You listen way more to his advice and what he says and take what he says seriously in the business aspect. But in the gym and the fitness aspect, you probably give him 10%. So this is basically the life aspect of you. So who are you? One way to see who are you exactly is you are the sum of your perspective. That's one way to imagine your personality or to construct your personality. Maybe you are 50% or 60% fixated on your money and business. So you spend a lot of time focusing on business, maybe forgetting to exercise or travel. Some people are more spiritual or consider them to be more spiritual than others. Some people learn languages a lot. I met people actually in Portland, Oregon that I speak at least fluently 6 languages. I was amazed by that. So that's definitely a big aspect of your life. I think Ali wanted to interrupt and say something, right?
Yeah, I just wanted to say I used to attend those courses with someone very talented guy. He has patents in his name and then recorded well globally. So he used to say, you cannot say, I made it myself 100%. You always owe someone something. If you don't owe anyone anything, you will owe the universe something. So the universe gave you tools, gave you even a coincidence that, came on your way, or let's say happens to be on your way that helped you achieve your goal. Yeah, so you always owe someone something.
I think this is a perfect way to say it about who you are, that how you are the sum of perspective. Exactly. Somehow someone has affected your life or your thoughts or your intellect in a way. And this is what we mean by you are the sum of your perspective, and each perspective is being affected or you owe somebody. That's actually perfect. I like that example. And or we can see it. You don't have to be necessarily a weighted sum of your perspective. You might we can imagine that each perspective of your life is just a dimension in your personality. So is this another model of how we can imagine that? We don't have to say that you are 60% fixated on money or 60 or 70%, for example, fixated on travel or languages, just a different aspect of your personality. And somehow these aspects are just like building blocks of who you are. So we are going to give this an official name, or we did not invent that, but it's already there, but we're going to give it a name here. We're going to call it the query value model. In that model, the life perspective is called an attention head. Your goal in that perspective or in that attention is called the query. Where you are in life in that perspective is called the key, and your value is just your knowledge, your status in life, your contacts, your money, and everything, basically your whole life. So another concrete example is the job search. Let's assume we have two senior managers. One is hiring. He is already employed. His key is a senior manager, and his value is expertise plus CV. The other one, they are both in the same context. The other query is he is looking for a job. His key might be senior manager too. He's not employed, so he's looking for a job. So they are basically this almost the same, but their query is different. Their query with regard to that life perspective is different. Now we will stop here, and the break that we said we will take from artificial intelligence, computer science, will stop here, and we have to go back to study, open the books, open the laptops, and we have to go back to study. So key model that we just mentioned, how we can represent this mathematically or how we can model it mathematically. This relates to what we said earlier. Representing daily objects and concepts in life in mathematics will enable you to harness the power and the magic and the well-established rule of mathematics to draw conclusions and make predictions. And the better that you represent them, the more accurate that you represent them in mathematics, the better the model, the better your conclusions and predictions will be. So let's see how we can model this QVK model mathematically. Basically, we already said that in the previous lecture that everything can be seen as a vector. You as a vector, I am a vector. The people around you can be seen as vectors. And the key, your key, which is your current status in the life aspect, also is a vector. The value is a vector, and the query is a vector. And basically, there is a key matrix and a value matrix and a query matrix. We just multiply your vector by the key matrix to get the key vector. You multiply your vector by the value matrix to get the value vector, and you multiply your vector by the query matrix to get the query vector. And that's why we have reviewed the matrix multiplication in the first slide. And we said that when you see matrix multiplication, you imagine always on the left side a matrix, on the right side a column, and that multiplication is just a linear combination of the columns of that matrix determined or dictated by the values or the rows in that vector or the scalar values in that vector. So we now have the key, the value, and the Q. Let us see how we calculate the new person or the new you in this type perspective. So here again, this is the query matrix by U, which is your query vector. And this is the key matrix of F1, let's say your first friend. You multiply the key matrix by his vector again, so you make a score. So you have two vectors. When you multiply two vectors together, that will give you a score. And then you have another friend here. This should be F2. So when you multiply this by your query, so it's always the key by the key vector multi dot product the query vector will give you a scalar value. So you have 5.1 and 4.3. So let's say there are a million people in your lives. You calculate a score for each person. And you feed all of these scores into a softmax function, and that will give you a probability distribution. Maybe there is one person that you're gonna pay 85% in that life perspective. And we have shown the softmax function, it just pushes some values higher based on their values. So if you have like the high values, gets higher percentages even further because it uses the exponential function. So here just we say that after we calculate the percentages based on the softmax function, and again the values that are input to the softmax functions are based on the scores, and each score is when we multiply the query vector by the key vector, which gives us a scalar. This is just a weighted sum of all the value vectors. So, and we said that the value is just this person's expertise in that specific aspect of life or opinions or intellect or whatever, and this is also your value. So F1 represents person 1, F2 represents person 2, F3 represents person 3, and so on. This W represents how much you are affected by that. It's just a scalar multiplied by a vector. And again, a matrix by a vector is just a vector. So up to this point, we have covered the idea of the QVK model and how we can represent that mathematically in terms of vector and how we can extract from each vector a query, a value, and a key. We just basically assume we have a query matrix and a key matrix. You might ask, Ali, how do we get these matrices? We will come to this. For now, we're going to assume that these matrices are given to us. But in reality, when you have a machine learning task and you train, you can assume these matrices as just variables or part of the machine learning model that you are trying to learn. As we have said in Where to Vector in the previous presentation, when we learn the vector embeddings, we input the hot or the sparse vector, and then we learn the embeddings. Same idea here. We just assume that they are just W1, W3, everything in this matrix, everything is scalar in this matrix is a variable and is part of the machine learning model. So at the end, we have an error function, and this error function will be minimized, and in the process of minimization, we will discover each of these. So let's go back to the positional encodings. What is a positional encoding? A positional encoding dictates that the relative position of an object in a certain context affects the representation or the value. So we need to apply, what that means mathematically is that you need to apply some sort of a transformation to that value or that vector. Now we are in the linear algebra space, so we speak in terms of vectors. So let's take an intuitive example. These four images shows exactly the same person, the same suit, the same place, same everything, same office, same company, same job title, same salary. Everything is fixed. Everything is fixed. However, his Tuesday, if you look at Tuesday, we are at the beginning of the week, he's a little bit energetic. Wednesday, he feel a little bit less energetic, maybe a little bit exhausted. Thursday, you can see the fatigue start to show on him. Friday, he come with to go home. So that's just for us to imagine the effect of position or the positional encoding. So how do we model the position encoding mathematically? Now, this is just a concept. This is an abstract concept. There are many ways to model that in mathematics. One way is to imagine that Monday, we assume that Monday has a vector, Tuesday has a vector, Wednesday has a vector, Thursday has a vector, and Friday has a vector. And then you just add any vector according to its position, or the day it appears in to that vector. So if you, Ali, for example, you are presented as a vector, you appeared in Wednesday, we just add the vector that represents you to the vector in Wednesday. And again, how do we know the value in the of these vectors? Usually when we are within the context of machine learning model that is being optimized, and we try to figure out the parameters and the weights of that model, part of the learning process or part of the minimizing the error function or the loss function, we will figure out the value of these vectors. So we assume them that they are W1, W2, Wn, depending on the dimension of the initial vectors that we feed into the neural network. So that's a very simple model. You just add a vector to another vector. There are other positional encoding methods. Or before we talk about these positional encoding methods, let's talk about a little bit about one of the disadvantages. Ali, can you think about a disadvantage about this method here out loud?
Yeah. I would say when you have plenty of positional vectors that you need to cater for, having a
Exactly.
large
If
one,
that's
yeah.
exactly when you have a lot of positions. If we are modeling, or suppose that the input to our machine learning model was just the 7 days of the week. Assume that we are modeling a century or 1,000 years, and we want to even take it to the granularity of a second, which is this is not real, but we need to explain the idea that so many vectors, so many positions, that mean we need a vector for each position. So again, this is a way to model it, and actually it's being implemented in machine learning, but this is one objective, and it works. The model works and is being productive and accurate in predicting what it's supposed to predict. So this is a mathematical model, and we like to explain this because of its simplicity. The idea behind this is that you have a concept, you can, and the takeaway is just not to learn generative AI, or, for example, generate the transformer architecture or these generative models, is to learn the mathematical modeling behind it. Today we have generated AI, tomorrow we have a new technology. And what's gonna stick is the basics. How did we model these things? These are very basic concepts. And once we see the transformers, it's just a little bit extra modeling that made that revolution, as we will see. So there are, so Ali, thank you for that answer. It conveys the idea very well. So we have other positional encoding methods such as rotary positions, fixed sinusoidal absolute. These positions transform the vector in different ways, and it does it consistently, so it is not affected by how many positions we have, or if we say the context of the input to the machine learning model. It's going to do the same thing regardless. If you have 1,000 input, we don't need to have 1,000 positional encoding vectors. So let's move to the transformer architecture that everybody these days talk about. Again, we're going to go back to the life analogy and our life aspects. As we live our lives, we go through different stages. For example, we are today we are undergrad. Tomorrow we might go to grad school. After that, we're going to go to our first company, and then the second company, and then maybe you become a CEO. Each of these stages of your life can be thought of as a transformer block, or a part of the transformer architecture. That's called the stage. And inside each stage of those, you have, and inside each stage of your life, you have different aspects to pay attention to in your life. When you are undergrad, you might not pay attention to the money aspect a lot, or even the money aspect might not be even a perspective in your life at that moment. Maybe there are different aspects. And then after you graduate, now you are starting to look at the money perspective. You have probably taken a loans, and then this represents the actual transformer architecture. You jump from a stage to stage, and each stage you have different aspect in your life, and each aspect, different people will affect you differently. So this is what we were describing is the transformer block. Each you, and let's say everybody in the world, goes through a stage, the same stage, and each before they go to through that stage, or as they go, we go, they have different aspects of their lives, and each aspect is called an attention head. and each attention head, you form your news, you form that perspective of your life, and then somehow this is the new you based on all the perspective of your life and how each person affected you separately. And then we have shown a little bit the mathematics behind that is how we multiply this vector by the weight matrix, by the value matrix, the key matrix. And then after you form your new self based on your perspective, you go through that stage. And this stage is basically a neural network. And then after the neural network gets its output, that's the new you after you finish that stage of your life. So basically, that transformer block is very simple. Here we have matrices, 1, 2, 3, and then we have also weighted sum of vectors. And then each attention head will participate a little bit in that vector and each of these vectors. And after we get the final vector, you go through a neural network, and the neural network give you a new vector, or each of those guys actually here will get a new vector because each of them in a specific stage of their lives, they have different objectives in every aspect of the life. So this is the infamous picture that is all over the internet, which is the transformer architecture, or specifically the decoder transformer architecture. And this actually is just shows that the input or a bunch of vectors that representing you, your friends, you go through a stage together. So this is a multi-head attention that we have described, which is represents multiple stages in your life. And it will, for each person or for each vector, it will produce a new vector. And that vector that it produces is added to your original vector. That's why there are two arrows here. I like that they have drawn explicitly. They called it add and norm. We'll talk about normalization in different slides. It's not that big deal. But this is what they mean by add. That means the value that you get from others for each different perspective of your life. And then you go to the feed-forward network. And again, that stage of your life will add a little bit about your personality. And then that's they call it add and norm. I really, again, like these arrows a lot. And again, you finish that stage of your life. You finish your undergrad, you go to grad school, you go to your first job, you go to Intel, you get laid off, and then you find a job at NVIDIA, and so on. And life goes, keeps going. That's basically our presentation. I hope that we have simplified it. And we didn't go actually a lot in math deeply for one reason is that it's really here about modeling. I think that the revolution behind the generative AI was about just a new way to model things. And then the math, as we have seen, really simple.